Hi AB Calculus class. We are working on 2017 number 3. This is an FTC question. Any questions from 2017, 18, and 19 are more going to be like your AP exam now, where topics can sometimes add some additional things in here. But this is a standard FTC question. It's going to be on your AP exam, folks. I want you to know this stuff so well. So let's go ahead and look at the question. The first thing you notice is they gave you a graph of f prime x. It's made up of a line, a semicircle, and two other lines. And they gave us this initial ordered pair here. Very important. The very first thing they want you to find for part A is they say find f of -6. Alright, well, we've done this on two of the three other ones. The area underneath, this is the graph of f prime x, the area underneath f prime x from -6 to -2. If you take the antiderivative, you'll get f of x. And then if you plug in the top and the bottom, you get f of -2. So you plug in the top minus and then f of -6. And this equation here is what we rearranged to come up with our two quick ways to memorize things. If you were to get this by itself, you'd end up with initial plus net change. So you have, you got initial plus net change if you got this by itself. So final is initial plus net change, or initial is final minus net change. So the idea is that the area underneath f prime x gives you the net change in the antiderivative. How much does the antiderivative change by? Okay, so in this problem, we have this, we want to know this, and we have this. If I compare these two on a number line, -6 comes before -2. So -6 would be considered the initial, so -2 would be our final. So if we're using our nice little shortcut, initial is the final minus the net change. So we need to know what's the area underneath f prime x from -6 to -2. So here, f of -2, again, is the 7, minus, and I need the area from -6 to -2. Okay, you will notice that this area here, from -6 to -2, is a triangle. Triangle is 1/2 base times height. So it's 1/2. The base of this triangle is 4, the height is 2. So the base is 4, the height is 2. And folks, you actually don't need to simplify it. I'm going to simplify it because way later on in the question we're actually going to need to know this. So I'm going to simplify it, but you don't have to. This right here, if you multiply this is 4, so 7 minus 4 is 3. So f of -6 is 3. However, I would just leave it like this. That's fine. Okay, that's the first part of it, part A. The second part is to find f of 5. And we're going to go through the same process again, but instead of -6 and -2, we're using 5 and -2. So same idea. All right. So again, I want this. I have this. If I compare them on a number line, this comes before this, so this is our initial. And we're looking for our final. So it's our initial position plus our net change in position. So again, the area underneath f prime x gives the net change in f. So this tells me how much f will change from -2 to 5. So to find f of 5, we have our initial, which is 7. They give us that information at 7, plus the net change. And the net change here, yeah, that's fine, is the area from -2 to 5. Well, to go from -2 to 5, we first have to go from here to here, which is a semicircle. So a semicircle, so this area starts off with a semicircle. A circle is pi r squared. The r here is 2. That would be a full circle, but it's not a full circle, it's half a circle. So we're going to put a half in front. But one more thing, the area is below the curve. So you have to remember the area below the curve counts as negative area. So that's the area of half of a circle. It's negative because the net change will be negative when it's below. All right, but we only went from -2 to 2. We didn't finish getting all the way to 5. So to get the rest of the way to 5, we have a triangle. You could break this up into true triangles. Don't do it, folks. A triangle is 1/2 base times height. That's the base. That's the height. So it's 1/2 base times height. The base is 3 and the height is 2. Okay. That's it. You'll notice it's positive because the triangle here is above the curve. All right. Do I need to simplify this? Not at all. If I did, and again, I'm only simplifying this in this one problem because I want it to be easier for you to see later on. You should leave your answer for this, for f of -6. You should leave your answer like this. But I'm going to simplify it just because later on it'll make it easier for you to see the final answer. Here this is 7. If you multiply this triangle here is a 3, and there's no negative to distribute, so 7 plus 3 is a 10. And this is a negative. 2 squared is 4, half of 4 is 2. So this is f of 5. I would leave it like this, but if you simplify it, it's like this. And I'm going to write these two off to the side because we're going to need them later on. F of -6 is 3, and f of 5 is 10 minus 2 pi. All right, that's a lot of work, but that's all of part A. Okay. All right, so let's look at part B. Part B simply says, when is f increasing? Well, folks, if you want to know when is f increasing or decreasing, or has relative maxes or mins, you need a sign chart of f prime x. So to find out when f is increasing, decreasing, maxes or mins, we want a sign chart of f prime x. You make sure you label this. If you're not labeling stuff, you got problems, okay? So my sign chart will go from -6 all the way to 5. And we want a sign chart of f prime x, and what graph do we have? F prime x. So what goes on a sign chart? Well, we need to find out where things are equal to 0. So when is f prime x equal to 0? Well, it's only equal to 0 here and here. It's also equal to 0 there. It's already on our sign chart, so we're not going to have to write it again. So -2 and 2. By the way, if they ask for what were the critical points, very, very important. I want you to hear this. My critical points are where the derivative is equal to 0, -2 and 2, but they can never include the endpoint. So even though 5 is where f prime x is equal to 0, it could never be a critical point. Critical points are where you can win max or min awards or points of inflection. The endpoints can't win that. They can only win the absolute values. So they can't win relative max or mins, or they can't be points of inflection. So if someone did ask critical points, you would not mention these. These are my only critical points. And now my sign charts. You will notice the graph is above the curve, below the curve, above the curve. So here we have positive values, negative values, positive values. And this is all we need. They ask, when is f prime x increasing? And remember, this tells me f of x is increasing, decreasing, increasing. So I would say f of x is increasing from -6 to -2, and 2 to 5, and now y. When it comes to the y, if you don't justify, you don't get points. You talk about what you saw in the sign chart. Why? Because f prime x, you can either say is greater than 0 or f prime x was positive. I like saying f prime x is greater than 0, but anyways. Remember, when f prime x is positive, graph is increasing. If it's negative, it's decreasing. Okay, I'm going to leave the sign chart up here, but that's it for part B. Okay. And the reason I left the sign chart here is now if we read part C, they say find the absolute minimum value of f. Absolute mins. Absolute minimums can occur at endpoints or critical points. So, on my sign chart of f prime x, I already have endpoints and critical points. Those are the only values that could even win absolute max or absolute min awards. So all we need to know is what are the values of f at those points. So what is f of -6? Well, I already found it. It's 3. What is f of 5? I already found it. It's 10 minus 2 pi. What is f of -2? They already gave it to me. f of negative 2 is 7. Now, we don't know which one of these could be the min or max, but there's one that we don't even know, which is f of positive 2. Now, the reason I want to bring this up is not everyone can win the absolute max or min awards. They can win some of the awards, but we need to see which ones are actual candidates for minimums. So if I use this sign chart, it tells me f of x was increasing, and then decreasing, and then increasing. Which are the only two that you could win a minimum at? That could be a minimum, and that could be a minimum. So I don't even have to consider these two. These two can't be mins. They could be the absolute maxes. These are the only ones that are candidates for the absolute mins. Whoa, 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 whoa. Back up, back up, back up. Sorry. Those are absolute maxes. These are the only ones that could be absolute minimums. So we just need to find the two values and compare them. I already know f of negative 6. So now I just need to find what is f of 2. All right. So now we got to find f of 2. And guess what you get to do? You get to go all the way back to what you did in part A. To find f of 2, we have to use f of negative 2. If you compare these two, this comes before this. So this is my initial. I'm looking for my final. So when I'm looking for my final, it's initial plus net change. So I need to know what's the area underneath f prime x from negative 2 to 2. So my initial I'm given is 7, so it's 7 plus, and now I simply need the area of this half a circle. So the area of a half a circle, we did it earlier, it's, because that's negative 2 to 2. Negative 2 to 2 is just this half a circle, so it's simply 1/2 pi r squared. The radius we already said in this is 2. And because the area is below the curve, again, we got to have a negative in front. So if we just simplify this, f of 2 is 7, and then this is 4, half of 4 is 2, so minus 2 pi. 7 minus 2 pi. All right, so these are the only ones we have to look at. Which one is a lower number? Is 3 or 7 minus 2 pi lower and you don't have a calculator? Well, if you can just remember, pi is 3.14. Let's just even use 3. Pi is 3. So 2 times 3 is 6. 7 minus 6 is 1. 1 is lower than 3. So, here is what I would say. I would say absolute minimum could occur at, and remember, not all these were candidates. These were the only two candidates. At x equals negative 6 and x equals 2. F of negative 6 equals 3. F of 2 equals 7 minus 2 pi. So you just look at those two. Therefore, f of 2 equals 7 minus 2 pi is the minimum, is the absolute minimum. And there you go. Now folks, when they said the absolute minimum, they didn't want the x-coordinate. X-coordinate is the x-coordinate. They wanted the y-coordinate. So 2 isn't the minimum. 2 is the x-coordinate where the minimum occurs. The minimum value is 7 minus 2 pi. All right, that's the end of part C. Let's go to part D. All right. Part D asks us to find two things. The first thing they ask us to find is f double prime negative 5. Now, nice and simple, f double prime negative 5. If this is the graph of f prime x, and we want to know about f double prime x, we want to know about the derivative. So we want to know the derivative of this at 5. So we're just looking at the derivative. And remember what the derivative is. The derivative is the slope of the tangent line. So we want the derivative of this guy. The derivative of f prime x is f double prime x at negative 5. The derivative means the slope of the tangent line, so we just want the slope of the tangent line at 5. So negative 5. So I'm going to go to negative 5. And the question is, what's the slope of that line? Now, several ways of doing it. You could just do old school slope, or you can count rise over run. Like I'd probably just say, all right, my slope is, it goes down to over 4. And you could simplify it to negative 1/2. You don't have to. Or you could have done, you know, hey, this is the ordered pair negative 6, 2. This is the ordered pair 2, 0. And you could have subtracted the y's on top. 0 minus 2, and then 2 minus negative 2. It doesn't, oop, that's a negative 2. But anyways, there you go. You just count rise over run for slope. Or you could use old school slope, y2 minus y1 over x2 minus x1. That's the first one. And then the second one is, what is f double prime 3? It's the same idea. It's what's the slope of the tangent line. I want to know what's the slope of the tangent line right there. I want to know what is the slope there, or the derivative there. But there's a sharp turn. So it does not exist because f prime x has a sharp turn at x equals 3. And there you go. That's the end of the question. Have a good day.